Our topic this afternoon is space. And I want to start by stating unequivocally that there is no such thing as space. Whether viewed as the infinite void of the Greek atomists, or the receptacle of Plato, or the absolute cosmic reference frame of Newton, or the acrobatic contracting and curving frame of Einstein, or the final frontier of James T. Kirk, there is no such entity. So this lecture is like the old Seinfeld show. It's a lecture about nothing. Now, you might think that should leave plenty of time for questions. But surprisingly enough, I have a lot to say about nothing. Space is a particularly insidious kind of nothing. When physicists treat it as a thing existing independent of physical bodies, they detach the concept from its actual reference in reality. And a detached concept can be like a runaway train, destroying everything in its path. The concept of space lies at the interface between philosophy and physics, not falling neatly within either field. It is too narrow to belong to metaphysics, which deals with the nature of existence as a whole. On the other hand, the concept can be fully understood without specialized knowledge of physics, which studies the basic nature of matter. Space is similar to the ideas of metaphysics in that the data relevant to forming the concept are available to any man in any era. They were as available to Aristotle as to Einstein, and we will see that Aristotle understood the concept much better than Einstein. Now, I've already told you there's no such thing as space. Now, let me undercut your motivation further by saying that the concept of space, properly understood, is not even very important. It has some valid uses, but I do not regard it as one of the crucial concepts at the foundations of physics, like force or mass. So why am I giving a lecture on it? Well, its uses may not be important, but its misuses have been. Throughout history, confusion over the concept has wreaked havoc in physics. And that's my subject for this lecture. What I will give you is a history of the concept of space as an example of how rationalism and the failure to grasp the proper principles of metaphysics can give rise to a floating concept that destroys every thought process it touches. The Greeks had assumed the universe was finite. But when the atomists put forth the idea of empty space as a separate reality distinct from matter, they were driven to accept the idea of an infinite universe. For what could limit the extent of empty space? Since empty space was nothing, there didn't seem to be any sense to the claim that it stopped at some point. They didn't want to say that the nothingness only extended so far, and beyond that there was really nothing. Now, Aristotle recognized that we don't start with the concept of space. We start by observing entities, their relative arrangement, and the changes in that arrangement. Those observations give rise to the concept of place or position. The concept of space then merely names a sum of places. For example, if you bought a new house, you might walk into an empty room with your spouse and ask, "What are we going to do with this space?" Now, that would be a perfectly valid use of the concept of space. What you mean is, we have a sum of places. How are we going to arrange the items of furniture? In other words, how are we going to place them with respect to one another and the surrounding walls of the room? What you definitely don't mean is, we have a hunk of empty space here, of nothing. Do we want to keep it here or maybe move it out into the backyard to make room for some furniture? Now, that may sound silly, but Aristotle points out that it is precisely that kind of silliness that characterizes his predecessors' views on space. They treated space as if it were a thing with its own separate existence apart from bodies. But in fact, the concept of space derives from the earlier concept of place, which refers to relationships among physical entities. Space does not exist apart from bodies, because relationships do not exist apart from entities that are related. What exists are entities. Attributes, actions, relationships, are attributes, actions, relationships of entities. Talk of empty space that exists independent of entities makes no more sense than talk of movement without things that move, or color without things that are colored. There are no regions containing nothing but disembodied relationships. A place is a place of something. Now, in addition to rejecting the void, Aristotle also rejected the possibility of actually existing infinities. Infinity is not a quantity. It implies the existence of something indefinite without identity. To say that there are an infinite number of atoms or an infinite amount of space makes no more sense than to say you have a jar of marbles that contains no particular number of marbles. To be is to be something in particular, so infinity is out. The universe is a finite plenum. Now that is the essence of Aristotle's view, and it's a view I entirely agree with. And let me just make a connection here. Now if I talk about apples, okay, it's very natural, if I ask you to think about apples, it's very natural for you to form an image of an apple in your mind. Now, a lot of you probably have images of apples in your mind right now. Now, there's nothing wrong with that. But when it comes to the universe as a whole, if you do that same thing, if I say universe, and you form that image, what in the world perspective are you forming it from? I mean, you are taking the perspective of being outside the universe and looking at it. And what do you picture in your minds? Maybe a spherical region with a bunch of stars and galaxies, and then what, a region outside that doesn't have those stars and galaxies, with you standing outside there looking. Now, that is not a helpful picture. And when you think of the universe, if that's the picture that comes to mind, you simply, with an act of will, have to purge it from your mind and give yourself the absolute rule of always taking the perspective from within the universe. There is nothing else. Now I want to give you some hints and see if you can guess the next important development in the history of space. Consider the attributes that space is said to possess. It is independent of matter. It is ubiquitous but not perceived. It is infinite, eternal, and immutable. Now, does that remind you of anyone? It doesn't have to be someone you know personally. Just shout it out. God, of course. It didn't take people very long to make the connection. Theologians felt very strongly that they should have a monopoly on the infinite, eternal, and immutable business. And they regarded it as unacceptable for natural philosophers to set up shop next to them and talk about space as something that shared many of God's perfections, but was independent of God and didn't constantly harangue people with a lot of commandments. I mean, Einstein didn't actually talk about nothingness having properties, or even the vacuum, which is another term that most physicists today use. Einstein talked about fields. But the problem was that he never gave any physical meaning to the concept field. I mean, this is a major problem in physics today. That, I mean, it sounds like they're talking about something physically real, but in the end they always deny it. If you ask them to define a field, they say, well, it's a mathematical equation that assigns numbers to points in space. So you're left with nothing.
If fields are problematic in explaining phenomena like electromagnetism, then what is it I am seeing with my iron filings and my magnet?
Oh, I hope I didn't give anyone the impression of saying that I reject the concept of fields. I wish they would give it a physical definition, rather than saying, if you ask them what a field is, saying that it's a mathematical function that assigns numbers to space. That's silly. What you're looking at when you see a magnet moving iron filings is there is a physical something that is going from the magnet to the iron filings affecting their movement. And if that's what you want to call a field, then fine, give it a physical definition. But don't define it as a mathematical function, because I can almost guarantee you that there is no mathematical function going from the magnet to those iron filings causing their movements.
See, I thought you were attacking the idea of reifying the field in some way, yet they sure look like lines of force to me.
No, I wish they would reify it. And make it something physical as opposed to a mathematical function.